Now, welcome to class again. So today we're going to be discussing about projectile motion. So what is a projectile? Number one, you have to understand what a projectile is. And at the end of this class, you should be able to explain what a projectile is, the kind of motion a projectile undergoes. You need to also be able to, you should be able to state, use the formulas to calculate the time of flight from the starting point to the end point. Then you also need to, you must be able to calculate the maximum height, the horizontal level. You should be able to use formula to calculate the range. So at the end of this class, you should be able to state some examples of projectile in our everyday activity or everyday life. So what is projectile? A projectile is an object that is thrown into space freely under the influence of gravity and air resistance. A projectile. So a projectile is an object that is launched into space and moves under the influence of gravity and air resistance. So we have look at this example. When a boy throws, this boy throws a stone or let's say catapult. This is the starting point. The catapult goes through this path. The path taken by a projectile is called trajectory. And that path is a parabolic path or curve. You will see this diagram, this shape is not a semicircular shape, it's parabolic. Maybe if I've drawn it this way, you understand. This is the real shape of a parabola. For those of you that you are technical students, you should have drawn this in your work. So the path taken by a projectile, when you throw it up, there's something that happens. You throw it with this is the y-axis and this is the x-axis. You throw it with a certain velocity. The velocity is u. So the object continues to move. That velocity, as it's moving against gravity, it continues to decrease until it reaches a final velocity at the highest point, and at that highest point Vy equals to 0. Then before momentarily it's at rest momentarily at that highest point before it starts moving back again. So if you are going to draw this, you have something like this. This is the Vy and this is the Vx. So we can get the component vectors of each side. Let's draw. So it was inclined, this object was inclined at an angle of theta degree. So let's bring it out. It is theta and this is our u. So we can find the uy. That's the vertical component of the velocity. Are you with me? And this is the horizontal component of the velocity. So we can say the vertical component is u sine theta and ux is what? U cos theta. Equation 1, equation 2. So with this, and so we want to calculate the, let's start with the time. To calculate the time it takes this projectile to move from the starting point, the point of projection. This is the point of projection. the time of flight, that's not the time of flight. We mean the time it moved from this point of projection to the highest height. So there are two times. Look at it. We can separate the time. The time it's used to move to this point, and the time it took it to come back. They are same. They are the same. So this t, this t. So okay, when I start the mathematical analysis of it, you understand that. So let's look at the time now. Let's make use of the first equation of motion under gravity. Remember, v equals what? U minus gt. Why am I using minus? Because I'm considering the motion of the plane, right? For this, we want to consider the vertical motion. We are considering what? Vertical motion. So we can write it as Vy. Okay. So from here, we have making Vy equals to 0. You have 0 equals to Uy minus gt. Then gt equals to, bring gt to this side. You have gt equals to Uy. Now make the solve formula and bring, let's call this equation 3. Put equation 2, put equation 1, put 1 into 3. You're going to have t equals, what's our Ui? U sine theta over g. This is the time taken from the point of projection to the highest height, or the time from the highest height to this. So since our time of flight equals to 2t, then time of flight can be written as 2u sine theta over g. Note this formula. Now, the next case is when we're talking about the maximum height. Maximum height. At maximum height, we have confirmed that for maximum height, Vy is 0. So let's look at a scenario here. Making use of this 2v squared equals to u squared minus 2gh. Do we still remember? Under motion under gravity. So let's say Vy, since maximum height is a vertical distance, so we are using Vy. So Vy is already what? 0. Because at maximum height, your final velocity is 0. Then use y squared minus 2gh. Now take 2gh to this side. 2gh equals to uy squared. Make h solve the formula uy squared over 2g. What is uy? Let's call this equation 4. No, equation 4. And this is what? Equation 5. Put equation 1 into 5. So we're going to have h equals to u sine theta all squared over 2g. This will give us h equals to u squared sine squared theta over 2g. Notes this equation. Okay, so to calculate range, this is the maximum height. This is what we call the maximum height. The range is the horizontal distance from the point of projection to the point where the projectile returns to the ground again. So the horizontal distance, in this case, we are no longer talking about the vertical distance. So vertical components become 0. Now distance between the point of projection and the point where the projectile returns to the ground again. Of S, you remember this h equals to ut, abi? Ut plus, let's say, minus half gt squared. Do you remember this? ut plus half gt squared. Now, since we are dealing with h is, let's now change it to r, because we are dealing with what? Vertical range, horizontal distance. So this will be what? R equals what? U x t. No, there is no acceleration. So g equals to 0. Because we are dealing with what? Horizontal motion. So acceleration is not affecting it. Do we understand? So g equals to 0 here.
It's always 0.
In this case, this is horizontal motion. So g becomes 0. So what is ux? Ux is what? U cos theta. What is t? U sin theta over g. This will become 2u, no, u squared.
Yes.
U squared.
Cos sin theta squared.
No, this t is not the small t, is the bigger t, because we are looking at the time from here to this place, not time to this place. I follow you. So we are using equation 4 in this. So we have 2u sin 2u squared, right? Sin theta cos theta over g. I can bring this 2 inside and say this is what? U squared 2 sin theta cos theta over g. From trig identity, sin
theta cos theta is
2 sin theta cos theta gives us 2 sin 2 theta. This is a trig identity. So this sin 2 theta, we're going to put it here now. So we have what? R equals to u squared sin 2 theta over g. This is the formula for range. Now there is a situation when we may be asked, what is the maximum range? The maximum range is when R max is got when you have your theta to be 45 degrees. That means maximum range happens when your angle of inclination is at 45. Note it. So this will give us R equals to u squared sin 90. Sin 90 is what? 1. Are you following? So this will give us what? U squared over g. So R max, the formula for R max is u squared over g. That's how to derive all the equations of projectile motion.